So, note, a fail to reject H-naught decision in a significance test doesn't mean that H-naught is true. Remember, I told you, we never tell them that we're true. We just say we don't have enough evidence. For that reason, you should never accept H-naught or use language implying that you believe H-naught is true. All right, so we're always going to say we failed to reject H-naught. We never say that they're true, and we never say that we accept it. So, in a nutshell, our conclusion in a significance test comes down to this. P-value is small, we get to reject H-naught and conclude HA in the context. P-value is large, we fail to reject and cannot conclude this. So this is a really important little box to remember or to know, because it's kind of like the little cheat sheet with statistical testing, okay? So small p-value, you get to reject it. If there's not, it's failed to reject, and how to conclude it. There is no rule for how small a p-value we should require in order to reject. H-naught is a matter of judgment and depends on specific circumstances. But we cannot compare the p-value with a fixed value that we regard as decisive. But we can. We would call it the significance level. We write it as alpha, the Greek letter. When p-value is less than the chosen alpha, we say that the result is statistically significant. All right, so the p-value is smaller than alpha. We say the data is statistically significant at the level of alpha here. All right, so if the p-value is smaller than alpha, we say that the data is statistically significant at the level alpha. In that case, we reject the null hypothesis and conclude there is convincing evidence in favor of the alternative. So what that comes out to be is that if your p-value, okay, is less than alpha, so it's smaller than alpha, okay, then we reject the null, okay, and in favor of the alternative. If our p-value is greater than or equal to alpha, then we fail to reject. All right, so that's what we're doing. We will always compare our p-value to the given alpha level. Remember I told you that alpha, okay, the significance level, alpha is equal to 0.05 unless stated in the problem, unless stated differently in problem. So we'll always assume alpha is 0.05 unless they state it differently in the problem. So here we go. So if p-value is less than alpha, we reject the null and conclude the alternative in the context. If p-value is greater than alpha, we fail to reject. All right, and so and then alpha is always set before we actually do any testing. So if we look at this, when it says a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that the regular AAA batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they are completely drained. The significance test is performed using the hypothesis. So they get that the null hypothesis is that the mean is equal to 30 hours. The alternative is that it's longer than 30 hours, greater than 30. The mean is greater than 30. We knew that from the problem. Where mean is the true mean life, mu is the true mean life of the new deluxe AAA batteries, the resulting p-value is 0.0276, okay? So in the next couple chapters, we're actually going to have to find the p-value ourselves, but right now, they're telling it to you, and they're telling you it's 0.0276. What conclusion can you make at the significance level of 0.05? Well, you're going to take your p-value, and you will compare it to your alpha. So here's my p-value of 0.0276, and we compare it to 0.05. So the question is what goes here? Well, 0.02 is smaller, so we're actually going to eat the value of 0.05. So it is less than alpha. When my value is less than alpha, we get to reject the null. So if we reject the null, we're going to say that this mean is not true, and we are in favor of HA, the alternative. So which means we get to say they're wrong and conclude that the mean life of the new batteries is longer than 30 hours, or longer than the previous regular AAA batteries that they have. And so it would look like this. Since the p-value of 0.0276 is less than alpha, which as I said, the sample result is statistically significant at the 5% level. We have sufficient evidence to reject the null and conclude the company's deluxe AAA batteries last longer than 30 hours on average. Okay, that's exactly what we conclude, how we got there, and why. The result is statistically significant. So when it's smaller, it becomes statistically significant, and then it's at whatever level you're working with. What conclusion could you make at the significance level of 0.01? Well, when alpha is 0.01, my p-value is no longer smaller than it, it's greater than it. So we would say since the p-value of 0.0276 is greater than an alpha of 0.05, the sample result is not statistically significant at a 0.01 level. We do not have sufficient evidence to reject the null. Therefore, we cannot say that the new batteries last anything longer than 30 hours on average. Okay? So here it is, again, written the other way, which is what I just said. Okay, so depending on your p-value doesn't change, your alpha level can change. So what happens is that alpha must be set before, okay, it must be set before the test. If we don't set our significance level before we take the test, so if we don't, or run the test, if we don't put alpha at 0.05 or 0.01 and we wait until after, we're considered to be manipulating the data because, oh, well, my p-value came out here, so I want alpha to be 0.05 so that I can reject the null, right, instead of 0.01. This must be set before you run any test.